In this video, we're going to discuss different past Regent questions where we are asked to determine which points or which coordinates make a linear equation true. This is question 4 from the August 2016 Algebra 1 Regent. Which chart could represent the function f of x is equal to negative 2x plus 6? Now we have 4 choices of charts containing x and f of x or x and y coordinates. What we need to do to answer this question is plug in the points from each table and see which one in which table do all of those sets of coordinates make the equation true. Let's start with choice 1. So we have the equation f of x is equal to negative 2x plus 6, and the first point that we need to plug in is 0, 6. So wherever we have an f of x, we're going to plug in 6. Wherever we have an x, we're going to plug in 0. So we see that 6 is equal to negative 2 times 0. This term falls out. 6 is equal to 6. Good. This point makes it correct. But before you choose choice 1 and move on to the next question on the Regent, you'll need to try each point in this table to make sure that every single point of the table makes the equation true. So let's try the next point, the next set of coordinates. We have 2, 10. So let's plug that into the equation. For f of x, we have 10 is equal to negative 2 times x, which is 2, plus 6. 10 is equal to negative 2 times 2 is negative 4, plus 6. 10 is equal to negative 4 plus 6 is positive 2. Since 10 is not equal to 2, the point 2, 10 does not make f of x equal to negative 2x plus 6 true, so the answer cannot be choice 1. Let's move on to choice 2. We're going to start with 0, 4. And we're plugging that into the equation. So f of x we're plugging in as 4 is equal to negative 2 times 0, which is our x coordinate, plus 6. 2 times 0, which is 0, so it just falls out. 4 equal to 6. Is 4 equal to 6? Since 4 is not equal to 6, the point 0, 4 does not make the equation true, so choice 2 is not the answer. Let's move on to choice 3. We'll start with the first set of coordinates, 0, 8. And plug them into the equation. F of x we're plugging in as 8 is equal to negative 2 times our x, which is 0, plus 6. Is 8 equal to negative 2 times 0? This falls out. Is 8 equal to 6? 8 is not equal to 6, so choice 3 cannot be the answer. Let's try choice 4. You could just pick choice 4 because we already tried 1, 2, and 3, and those were not the answer, but let's try it anyways just to make sure. The first set of coordinates we're going to use is 0, 6, and let's plug that in. So for our f of x, it's 6 is equal to negative 2 times x, which is 0, plus 6. 6 is equal to negative 2 times 0 is 0, so it falls out. 6 is equal to 6, so the first set works. Let's move on to the second set. Next we have 2, 2. Let's plug that in. For f of x, we have 2 is equal to negative 2, and our x is also 2, plus 6. Is 2 equal to negative 2 times 2 is negative 4, plus 6. 2 is equal to negative 4 plus 6 is 2. Since 2 is equal to 2, the next set of coordinates also works. Next, we have 4, negative 2. And we're going to plug that in. Our y is negative 2, f of x is negative 2, is equal to negative 2 times the x, which is 4, plus 6. Negative 2 is equal to negative 2 times 4 is negative 8, plus 6. Negative 2 is equal to negative 8 plus 6 is negative 2. This set of coordinates also works. And let's just try the last one. 6, negative 6. F of x is negative 6 is equal to negative 2 times our x, which is 6, plus 6. Negative 6 is equal to negative 2 times 6 is negative 12, plus 6. Negative 6 is equal to negative 6, and all of the sets of coordinates in this table makes f of x is equal to negative 2x plus 6 true, so choice 4 is the answer to the question. Let's look at another question. This is question 29 from the June 2016 Regent. Sue and Kathy were doing their algebra homework. They were asked to write the equation of the line that passes through the points -3, 4, and 6, 1. Sue wrote y minus 4 is equal to -1/3x plus 3. And Kathy wrote y is equal to -1/3x plus 3. Justify why both students are correct. There are multiple ways of answering this question. We're just going to look at one way. One way we can answer this question is by plugging in the points into Sue's equation and into Kathy's equation. And if both sets of coordinates make both equations true, then they're really the same equation, just written in different ways, and both Sue and Kathy are correct. So let's start with Sue. Her equation is y minus 4 is equal to -1/3 times x plus 3. And we're going to evaluate that at the point -3, 4. So for our y value, we're going to plug in 4. For our x value, we're going to plug in -3. So 4 minus 4 is equal to -1/3 times -3 plus 3. 4 minus 4 is 0. 0 is equal to -1/3 times 0. Anything times 0 is just 0, so 0 is equal to 0. And the point -3, 4 makes Sue's equation correct. Let's try the other point. Let's try 6, 1. Wherever we see a y, we're going to plug in a 1. Wherever we see an x, we're going to plug in 6. So 1 minus 4 is equal to -1/3 times 6 plus 3. 1 minus 4 is -3. -1/3 times 6 plus 3, which is 9. -3 is equal to -1/3 of 9, which is also -3. So the point 6, 1 also makes Sue's equation correct. So far we found that Sue's equation is the correct equation to pass through the points -3, 4, and 6, 1. Now let's look at Kathy's equation. Kathy's equation is y is equal to -1/3x plus 3. And we're going to first evaluate that at the point -3, 4. So let's plug that in. Wherever we see a y, we're going to plug in a 4. Wherever we see an x, we're going to plug in a -3. So for y, we have 4 is equal to -1/3 times x, which is -3, plus 3. 4 is equal to -1/3 times -3 is 1, plus 3. 4 is equal to 1 plus 3, which is 4. So the point -3, 4 makes Kathy's equation correct. Let's try the other point. Let's try 6, 1. And we're going to plug that into the equation. Wherever we see a y, we're going to plug in a 1. Wherever we see an x, we're going to plug in a 6. So 1 is equal to -1/3 times x, which is 6, plus 3. 1 is equal to -1/3 times 6 is -2, plus 3. 1 is equal to -2 plus 3 is 1. So the point 6, 1 also makes Kathy's equation correct. Therefore, both students are correct when they wrote their equations for the line that passes through the point -3, 4 and 6, 1.